The uncertainty in any property A, which we represent here by sigma sub A of a particle, it is given by the square root of its variance. Okay, so the variance is defined as the average of the square minus the average squared. Okay, so let's go ahead and verify the expression, the values for the uncertainty in the location and the uncertainty in the momentum of the particle. Remember earlier we've shown from our postulate that the product of the uncertainty of the momentum times the uncertainty of the momentum must be uncertainty in position times uncertainty in momentum must be greater than or equal to h bar over 2. So how do we solve for the uncertainty in x? Average x squared minus average x squared. So let's write the integrals that we need to evaluate there. This is going to be equal to, what's the average of x squared? Psi star x squared psi dx from 0 to L minus, what's the second integral equal to? Integral psi star x psi dx from 0 to L, and this whole thing is going to be squared. Okay? And we've already done this earlier. What's the average x? Do you remember? Average location. It's going to be L over 2. That's going to be L over 2 squared. What is this thing right here? You have to plug in your expression for psi and your x squared, right? So what you have to do there is integral of this thing right here is integral of square root of 2 over L sine, what's our n here? N equals 3. So 3 pi x over L times x squared times square root of 2 over L sine 3 pi x over L dx from 0 to L. So you need to be able to do that integral. Right? So what's the integral of x squared sine kx dx? You need to look, you can look that up, right? Or you can do it using MathCAD. So anyway, if you did this and you plug in the expression here and you do the same thing for the uncertainty in p sub x, you'll be able to show, in fact, that you're going to get an expression that's going to be larger than h bar over 2. Okay? Larger than or equal to h bar over 2, which will be consistent with the uncertainty principle. So how are we going to do this using MathCAD? This one? All right. Okay. So if we did this on MathCAD, what would we have to do? You need to, where is that toolbar now? It disappeared. Okay. What was it? We had to do x squared times the square of sine, right? Square root of 2 over L times sine n times pi. That's just times x over L. Oops. Squared dx. So that's the average value of x squared from 0 to L. Let's evaluate this. And that's the expression right there. Big one. Okay, I'm going to copy that over here. And I'm going to ask MathCAD to simplify it for me, see if it will simplify. It can't. probably can. Let me substitute n equals 3 first. Oh, let's try it. It's not going to be a simple simplification. It's not a straightforward simplification in MathCAD because you have to tell math. There's no way to tell MathCAD that n is an integer here. So let me go ahead and make a substitution. N equals 3, right? I'm going to copy 3 to the clipboard. And I'm going to substitute n equals 3 here. Variable, substitute. And there's a simplified expression. All right. So that is your expression, simplified expression right there. Assuming I've copied everything right. And then we can evaluate that. The L disappeared though, huh? What happens to the what happened to our L? There should be an L. Oh, I forgot that one. Okay, that 1/6 L squared expression has not been copied. Okay, let me do this again. I need to have that entire expression copied. Okay, so I left out the 1/6 L squared. So copy that. Okay, so now I'm going to substitute n equals 3. So copy 3 to the clipboard, go to symbolics, click on n here. Symbolics, variable, substitute, and there's your expression right there in terms of L squared. Okay. And let's subtract L over 2 from that one. What would that be equal to now? Oops, we don't know what L is. So that is your, what's that expression going to be equal to? That's the difference between this, minus L over 2 squared, right? This entire expression right here, okay, this is your average x squared minus the average of x squared, okay? So that would be the uncertainty in the location of your particle. It's time already? Okay. Well, I got 2 more minutes. Let's just finish this off. Oh, we're done. Okay. So anyway, let's make that your homework. Verify this entire expression right here, okay? That this is in fact, this expression, uncertainty in x times uncertainty in px is in fact greater than h bar over 2. Okay, just to verify that it's consistent with the uncertainty principle.